Okay, so 5.4 SDLC development persistence. Okay, a few of you have been asking about this topic generally, so it'd be good to learn more about it. First thing is like data, right? Now I know this is a pretty waffly topic, but it's like, what is data? Data is a facts that can be recorded, right? It's just information in a way. The formal way of thinking about it is the data is meant to be the raw stuff that you have, and information is what you derive from the data. Now, there are topics where we can talk about data and databases and whatnot, but we can simplify all of that and actually say, what is a big deal when it comes to data that a lot of you haven't been exposed to yet. And this is the idea of persistence. And persistence is where your program state outlives the process that created it. So think about, again, like 1511, where you like run, GCC, and you run your program. And your program runs and it stops. And every single time you run your program, you have like, it's like a reset, right? Like it's not like if you have a program that counts from 1 to 10 that you run it once and it goes to 10, you run it twice, it goes from 10 to 20. And that's because all of the memory, all of the data is stored inside the process that's running. Because how a computer works is that you have a when you run like / something, it starts up a little process. And this process like runs and does stuff, and then it ends, and then it deletes itself. So the whole point of persistence is saying, wouldn't it be cool if like while this process was running, it maybe talked to some kind of data store, database, that when the process ended and was deleted, all the data's still sitting there. And when a process starts up again later, it can keep acting on the same persistent data. How do we do this? How do we deal with this? Well, sometimes we use, like where is data stored? Well, it can be stored in caches, it can be stored on hard drives, it can be kind of stored on RAM, depending on what it is. But when we say persistence, we often will mean somewhere like if you restart your computer, it's still there. That's kind of what we mean. Because, if all these processes stopped, like think about it like with Flask, right? Like you've seen in the lectures, you run a Flask server, you can register multiple users. So it kind of feels like persistence because like the data's outliving the particular HTTP request. But if you stop your Flask server and start it again, it's like, nope, it resets. Because every time you start the process, it resets. So, we're going to talk about how to do some persistence for iteration 2. The comment here is that most servers, there are basically just a bunch of server code like Python and then a database, right? That's a large part of what the applications of servers are. Now, there's two ways that you can store your data. One of them you probably already know about, which is why we're not going to talk about it here. Or at least if you don't know about it, you could figure it out pretty quick, which is that you take your data and you store it in a JSON file. So, if I get a really simple server here, let me get like a auth-simple.py. And maybe we'll do it with JSON first. Let's get rid of most of this crap. And we'll just keep register for a second, and we'll make register even simpler. We'll basically say, all register is going to do is get a username and password, and it's just going to store the username and password. And it doesn't even need to. It could just return. I don't know. Return nothing for now. So again, if I print data when I make this request, right? If I go, print data, let's spool up this server and we can take a look at it. So if I run auth simple, okay, and then I'm going to go to Chrome, and I'm going to open up ARC, and then I'll try and call 15333/register, and I'll give it the payload, which is username and password, and if I click send, it returns me a blank. And you can see that every time I click send, remember how in my source code I printed out data? You can see that the first time I call it, I print out data before I modify it. So the first time I call it, it is an empty list. The second time I call it, there's one item in there, because that's the previous user I registered. Then there's 2 users, and then there's 3 users, right? So there's a few different users here. And every time I call it, it changes. But again, if I stop the Flask server and I restart it, and I call it again, it's blank. So there's a really easy way we could deal with that, which is we're like, you know what? Just before we return register, let's save the data to a file, to JSON. Then I could do that. I could say, you know, with open store.json write as file.write json.dumps. I know I could use json.dump, but I'll just do it this way. Data. Right? So just before I return it, I take the current state of my data, my global data, I turn it into JSON, and I write it to a file called store.json. And let's try that one. So now I'll come over here and I will click send, and we'll see if a file gets created here called store.json. It did. And then I have a look at that file and it's blank. Why is it blank? I've probably made a mistake and I don't realize. Oh, I don't know. Send. Oh, 500. What have I've got an error in my code. Sorry. JSON's not defined. Oh, classic. Sorry, I did this yesterday. Dumps. Because I imported JSON differently. I did from JSON import dumps. Well, JSON dump would I can't remember off the top of my head, but JSON dump allows you to basically write it directly to the file. Like, I think you can do something like that. It's basically just a shorthand version of the 2 lines above. So it's quite convenient. But, you know, I'm just taking the longer route here. So I go Python 3 here, I click send, it succeeds, and then I look at store.json and all my data's there. And if I click send a few more times, every single time that route's called, it saves it to the file. So this file's being overwritten. So now I'm kind of saving my data, right? Like, this is a form of persistence here. If I click send 2 more times, all the data's stored right here. And then we can play the other game, which is how do we get this data to be loaded up when we start? Okay, well, let's try that. We say when the server starts, we can set the default data to be this, but after that, let's say with open store.json read as file, you know, set my data to be equal to json.loads file.read. I don't remember a lot of this off the top of my head, but we can try this, right? So we want to open that JSON file. We want to take everything out. Like, we'll read everything from the file. We will then take it, turn it from a JSON string into real code, and then we'll set that to be our data. So let's try that. Let's see what happens when we start up our server. Jesus Christ. Loads. Nope, maybe. Let's try it out. If I click register, oh, look, we got all those users still. So if I click register a bunch of times, every single time I hit send again, it's storing it here. And when I stop the server and I restart it, they're all still there, because all my server does is it loads up that store.json. That's not too hard, is it? Like, you know, that's pretty manageable. I don't think it's too bad at all. You store your stuff like this. There's a few different ways to do this. Sometimes you can do it with timers and whatnot. But, you know, the other way is to kind of, you know, you abstract this into like a save function or something. You're just like, yeah, you know, like, I'll just call it save. Define save, and all it does is, you know, gets the data and opens that and does it, and therefore you can just hit save like that. And you could abstract this even further. You could be like, you could create you could call it save and return, where you give it a response object, and then you simply return dumps of the response object. So like rather than have to write save in every single function, if you assume that every single route is going to return a JSON object, you could just say, I'd like to return save and return my object now, you know, like this. Because then save and return will go and actually save the data and then return the response object that you pass in. There's some nice little, you know, clean programming ways to deal with this. But that's the basics of persistence. We're just storing this one as JSON. Now, what we're showing you in the lecture to do with Pickle is actually, like, this isn't even quite necessary. It's just an interesting concept. And for some of you who are implementing things with like classes and more complex data types, you'll actually want to use something like Pickle. Because here's the problem with JSON again. JSON can only store simple types: numeric, strings, lists, dictionaries. So if I try and do something here, like again, I say, you know, if I try and store a function for some reason, I try and store request.getJSON, the function, not calling it, but the actual function, like a function pointer, then this will crap its pants, because again, it will say that this function is not serializable. It does not know how to output this to a JSON file. Okay, so let's come back to that, and I'll show you the Pico library. So the Pico library is a way of taking any kind of Python data structure and basically turning it into a little zip file, and then you can unpack it later. So if we go to picklet.py, you'll see that very simple file. It looks kind of like the JSON one. We create a data structure, dictionary with one key, of lists of dictionaries, all the names, first and last. Now what we're going to do is we're going to open a file called export.p. So instead of export.json, it's like export.p. And then we'd like to write to the file. Now, the B here means binary. This is specific to Pickle. You just do it. You don't have to think about it too much. It's mainly because when Pickle writes to files, it doesn't write to it as ASCII. It writes to it as binary. And then just like JSON, we say pickle.dump. Or, I mean, just to make this the same as the other example, we could say, you know, file.write pickle.dumps. This is exactly what we had in the other file. So it's actually the exact same programming pattern as JSON. It's just that we're using a Pickle library. Like, the only difference here is the file type, the library we're using, and the fact that it's written in binary, right? So now if I run this one, this is not a Flask server here. This is just a simple file. I'm trying to pickle this data structure into a file. So Python 3 picklet. Oh, yep. I hit run. And you see it creates a file called export.p. And have a look at this. This is gibberish. This is useless. This means something to the Pickle library because it knows how to take this and decode it, but this doesn't mean anything to you. It's not secure. It's not secret again. Like, anyone with a Pickle library can decode it. It's just compressed. It's a little bit like if you took a text file, like a Hello World text file, and you zipped it up, and you tried to look at the zip file in a text editor, it would look like garbage, right? But we can unpickle it too. So if I go to this unpickle file, you see what I'd like to do, like the JSON thing. And again, I might do this another way, which is like, you know, with open, I want to open pickle.export.p in read mode as file. And then I want to say print pickle.loads file.read, right? I'm just trying to follow the same pattern as I did before, because there's different ways you could do this. So now if we try and open that Pickle file, unpickle it, we get that data structure. And again, the cool thing about the Pickle is you can do fancier things with it if you need it. Like, for instance, I could add the function pointer to the dumps function here, and it would be able to pickle it. And then when I go to unpickle it, I would actually be able to get, you know, my functions key has value of built-in function type dumps, you know. So yeah, it's cool. So that's pickling. It's just a way. It's less secure than JSON because you open yourself up to code injection, which is a bit of a problem. So in general, it's kind of like you would try and do something like persistence with JSON, And I've basically shown you how to do it here today. And if you need something more complicated, then you use Pickle. Gyurchan, that only reads the first data structure, right? I'm not sure what you mean by first data structure, because there's one data structure here. We saved that data structure to a file in a pickled format, and then we unpickled that file, which gave us that data structure. Are there any other questions about persistence? It's a pretty straightforward topic in Python, to be honest, so there's not a ton to do with it. But we'll see if it all makes sense. Pickle load only reads one thing at a time. Well, I don't know what read is. Like, if I'm like Python read whole file, how to read entire text file in Python, it's probably another method that isn't read's okay. I think it's okay. It should read all the lines. But I don't know. I guess the thing is, file read would read the entire file into a string. I'm not too sure. I don't know if there's whether your question about whether it reads one thing at a time, like if there's behavior I'm not familiar with, it'll be quite easy to figure out, because it'll behave like that. Okay, well, that's about it on persistence. This is what we want you to do for iteration 2. It's not only what we want you to do, but it will make things better for you, because you won't have to as you build more complex stuff, you won't have to register a user and create, if you want to test message delete, you have to create a user, make a channel, add someone to a channel, send a message. So persistence here can help with a lot of debugging. The last thing I'll say is that if you do create these export.p files or these export.json files, in your Git repository is a file called .gitignore. What you should do, we might have already done this for you. No. Is if you create this data store file, like an export.json or like a data store.json, then what you should do is add the name of that file to this .gitignore file, because you don't want to commit this file to the Git repo, because you'll just end up with a million Git conflicts, and the whole point is that everyone in your team should have a different data store. Do you know what I mean? It's not like you're all pushing the actual persistence to GitLab. You can all manage that separately. Let's take a 5-minute break, and that's all on persistence.